A list of the most influential people of all time wouldn't be complete without Sir Isaac Newton. Newton's laws are tied to almost everything we see in everyday life. They help us understand how cars work, how baseballs move, how anything moves. Isaac Newton was born on Christmas Day, 1642, in Lincolnshire, England. He was a tiny, premature baby who was not expected to survive the day. His father had died 3 months before he was born, leaving his mother to raise little Isaac on her own. Newton first attended Grantham School, and it was there that his early glimmers of genius began to shine through. His passion lay not in poetry or literature, but in technology and mechanics. He was utterly captivated, going on to invent his own intricate sundial, accurate to the minute. His potential and pushed him toward a more intellectual life, much to the displeasure of his mother, who wanted him to run the family farm. By his mid-20s, Newton had already invented calculus. Not bad for the son of an illiterate farmer. He would never meet his father, who died 3 months before his birth on Christmas Day in the small English village of Woolsthorpe Manor in Lincolnshire. He later moved on to study at Trinity College, Cambridge University, where he found a mentor in Isaac Barrow, the university's first professor of mathematics. Recognizing Newton's extraordinary talent and potential, Barrow encouraged him to tackle significant unsolved problems, including the development of calculus. During his time at Trinity, Newton delved into the works of several philosophers and academics, studying Aristotle, Plato, Gassendi, and Descartes. He was particularly captivated by Descartes' concept of the universe being governed by mechanical laws. Shortly after receiving his bachelor's degree in 1665, the bubonic plague ravaged Europe, taking the lives of an estimated 1 in 4 people in London. The pandemic forced Newton to work from his childhood home for the next 2 years, and that period led to some of his most remarkable breakthroughs. Using a prism, Newton discovered that white light and sunlight is made up of the colors of the rainbow. At the time, the widely held belief was Aristotle's theory that color was a mix of black and white. To prove his theory, Newton built a reflecting telescope that used mirrors instead of lenses, which resulted in a more accurate image. That was a lot safer than the time he stuck a sewing needle into his eye socket to see if altering his eye shape would change his perception of color. Outside the family home was also an apple tree. The famous apple tree. Legend has it that Newton was sitting beneath it when an apple bonked him on the head, prompting him to think about gravity, the force that brings things down. There's no evidence the apple actually hit him, but he did ask the question that helped unlock our understanding of the universe. Could the same force reach all the way to the moon? He reasoned that the same gravitational pull kept the moon orbiting around Earth rather than wandering off, and he believed this force could also explain the motion of planets in the solar system. The mathematics of the time wasn't sophisticated enough to determine the motion of these objects, so Newton invented his own form of math, calculus. There was a dispute over who actually invented calculus. When German mathematician Gottfried Leibniz published his paper in 1684, Newton claimed he had done the same work 20 years earlier. The thing is, Newton was so secretive that he hadn't made his efforts public because he couldn't stand the scrutiny. When Leibniz appealed to the Royal Society in London, Newton, as the Society's president, used his influence to make it side with him. Most historians now agree that the two men discovered calculus independently. In 1667, after the plague subsided, Newton returned to the university to continue his research as a fellow. He was a workaholic. Sometimes he'd forget to eat. In 1687, after 2 years of intense work, Newton published The Mathematical Principles of Natural Philosophy, commonly known as Principia. This revolutionary book introduced Newton's theory of calculus, his 3 laws of motion, and his theory of gravity, laying the foundations of our understanding of the universe. He explained how objects move and interact through his three laws of motion. This law suggests that every object in the universe attracts every other object, with the strength of attraction depending on their mass and the distance between them. This concept applies to everything, from apples to planets. Newton's work unified the movements of celestial bodies, like stars and planets, with the behavior of everyday objects under one set of physical laws. This showed that the same principles applied both on Earth and in the cosmos. Notably, Principia also marked a major shift in scientific methodology by using mathematics to describe natural phenomena. Newton's equations laid the groundwork for the quantitative techniques that are central to modern science. His true passion lay in research. It was through this work that he defined the law of universal gravitation and his three laws of motion. The first law describes how an object behaves when no force acts upon it. For example, a rocket stays still until a force is applied. The second law tells us that the more mass an object has, the more force is required to move it. A larger rocket requires more fuel to accelerate. The third law states that for every action, there is an equal and opposite reaction. The engine produces hot exhaust gases that flow out of the rear of the rocket. In reaction, a thrusting force is produced, pushing the rocket skyward. Newton may be considered one of the greatest scientists the world has ever known. Yet he actually wrote more words on theology than science. He believed the Bible contained the code to the natural world, and that, by carefully studying it, he could predict the future. Newton foresaw the apocalypse occurring in the year 2060, a period marked by war and catastrophe, followed by the second coming of Christ and the beginning of a divine new era. This religious side of Newton remained largely hidden until 1936, when Sotheby's auctioned off his theological manuscripts. They ended up with a Jewish scholar before being passed on to the State of Israel. 7,500 pages in Newton's own handwriting. He held unorthodox Christian beliefs, rejecting the Trinity, the belief in the Father, the Son, and the Holy Spirit, and fought against King James II's attempts to Catholicize universities. This led to Newton being elected as a member of Parliament, where he served 2 brief terms. Reportedly, the only thing he said on the record was to request that a window be closed. Newton also had another lesser-known side. He secretly studied alchemy for 25 years in search of a method to turn base metals into gold. In one manuscript, he wrote down a recipe thought to be a step toward creating the mythical philosopher's stone, believed by some to offer immortality. Unfortunately, Newton may have suffered mercury poisoning from all the time spent in the laboratory. Analysis of his hair after death showed high levels of the toxic metal, which scholars believe may explain his mental breakdown in 1693. He became paranoid, accused his few friends of conspiring against him, and suffered from insomnia and depression. The crisis lasted a year and a half. Not long after, he ended his 30-year career at Cambridge. In 1696, he moved to London to help run the Royal Mint. At the time, Britain's finances were in disarray due to the widespread practice of clipping coins and rampant counterfeiting. Newton brought scientific precision to coin-making and, as warden and then master of the mint, personally prosecuted counterfeiters, some of whom were hanged. In his later years, Newton focused on protecting and polishing his legacy. That sometimes meant erasing his rivals from history. One bitter feud involved the brilliant scientist Robert Hooke, who claimed he had inspired Newton's theory of gravity and sought credit. Newton, in turn, is accused of using his position as Royal Society president to eliminate the only known portrait of Hooke. None exists today. Newton ultimately succeeded in shaping the legacy he wanted. In 1705, Queen Anne knighted him during a royal visit to Cambridge, making him Sir Isaac Newton. He was a complicated man, reclusive yet desperate to be remembered. A man who devoted himself to his work at the cost of all hobbies, who never married. a man of science and also a man of faith. Isaac Newton died in his sleep on March 20th, 1727, and was buried at Westminster Abbey. His immortal legacy continues to shape our modern world.